So today we start the next topic, public key cryptography. So normally you know it very well. The block cipher classified two types. One is a private key cryptography. Another one is a public key cryptography. So already we discussed the private key cryptography. We can have a lot of example algorithm, AES algorithm, DS algorithm, triple DS algorithm, everything. So now we can move to the public key cryptography. Okay. Actually, in the symmetric key cryptography or private key cryptography, it can have some problem. Okay. For example, in the key distribution part, okay, what happens in the key distribution? Normally, one single key is used in the public key cryptography, the previous method. One key is used, the same key is used for both encryption and decryption. Okay, so another one thing, the authentication take somewhat problem. That means digital signature is missing. Okay, because anyone send it and then so after some time he deny it. That is possibility. Okay, this all the some problem in symmetric key cryptography or private key cryptography. So this was overcome in this particular public key cryptographic system. So the major framework for your public key cryptography is depending upon the characteristics only. Normally here you can using the two keys. One key is used for encryption, another one key is used for decryption. So the public key cryptography is also called as a asymmetric. That means asymmetric key cryptography. Okay, asymmetric key cryptography or public key cryptography or two key cryptography, all are the same. Okay, normally what are the main characteristics means? Normally it should be a computationally infeasible to determine the decryption key. Whatever you can give it to the cryptographic algorithm and encryption key. So normally you know it very well, the cryptographic algorithm in both asymmetric or symmetric model, it is a public one. So everyone know what the process is going on in that particular algorithm. But only one thing, how we can maintain your security means depending upon the key. Okay, the key only take the major part of this all the algorithm. Okay, so it computationally infeasible to determine, because in decryption key is another one key is used here. So normally whatever you have cryptographic algorithm or encryption key, it is not possible to determine the decryption key. Okay, so decryption key normally it is a private one. Okay, another one thing, normally it can have using the two keys. These are all the characteristics of public key cryptographic algorithm. So what is the main component of public key cryptography means? It can have again similar to your asymmetry model, plain text. Plain text means data that is fed into the algorithm as a input. Okay. Second one is here encryption algorithm. The encryption algorithm perform transformation on plain text. So using the encryption algorithm, we can give the input of plain text and a key to get your output of ciphertext. So that process is called as a encryption algorithm. Okay. Then another one component is keys. Keys means here we can using public and private key. Two keys are used. In the asymmetric key algorithm or public key cryptography, two keys are used. One key is used for encryption, another key is used for decryption. So the pair of key, one is a public key, another one is a private key. So every user normally generate the two keys. So before you want to communicate with other people with a secure manner, using this particular public key cryptography system. Okay, public key cryptography. So one is a public key, another one is a private key. Okay. So one key is used for encryption, another one key is used for decryption. So this is a third component. Fourth component, ciphertext. Ciphertext is a scrambled message. You know it very well. After do your encryption process, we can get the ciphertext. That scrambled message to send it to our sender via some internet or communication link. Okay. Next, fifth component is a decryption algorithm. So decryption algorithm accept a ciphertext and key as a input and produce the original plain text in the receiver side. Okay. These are the 5 major component or ingredient in the public key cryptography. So one is a plain text, another one is a encryption algorithm, then third one is a keys, public and private key, then fourth one is a ciphertext, then fifth one is a decryption algorithm. Okay. So how do your encryption in the public key cryptography? So here we can using the two keys, but once you can remember the previous method, symmetric key cryptography. Here, the encryption algorithm use here one single key, that is the secret key. The same single key or secret key used by the decryption algorithm also, but here not like that. So you can see this particular diagram. So normally user A want to communicate with user B, so you can perform some encryption algorithm means. So the plain text, you can get a plain text, then normally each and every user generate the two keys. Okay, user A generate the two keys, its own private key and its own public key. Similarly, user B create its own private key and public key. Okay, so the private key kept itself. That means it is secret one. It is only known by that particular user only. Okay, but public key is published or it can be announced in the any register. Okay, some public key register is there, the common register is there for all the authentication authorized user in that particular organization means. So one register is there. That register we can keep or kept in the all the public keys. Suppose a 10 user available in the organization means, so in the dictionary or directory or in the register, okay, anything you can use it. So you can put into your public key, all the 10 users public key. This is the concept. Okay, so now A want to transfer the message to B with a secure manner means, so the plain text, you can take the block of plain text, then perform encryption algorithm. Okay, so the encryption algorithm we can do along with the keys only. So what key we can use for encryption means, we use the user B's public key. We use the user B's public key. Because suppose A want to send a B means you can check the public key directory. So it is the public key directory, all the users key is available. Okay, so the B's public key is also available in the directory or registry. So the user A take that particular public key, then use it in the encryption algorithm to produce a ciphertext. So here we can use the two keys. One is a private and another is public. So in the encryption algorithm, normally we use it the recipient. What is B? B is a recipient. Okay, A is a source and B is a recipient. Okay, so normally in the encryption algorithm, public key cryptography, in the encryption algorithm, we use the recipient public key. You can remember the point. We use the recipient public key and perform your encryption algorithm, get to a ciphertext. Then the ciphertext reaching into the user B or recipient. So user A encrypted the encryption algorithm, done it and produced the ciphertext using the B's public key only. So automatically, so the B using its own private key only, it is possible to decrypt it. So no other user, it's not possible to decrypt the algorithm, because that type of mathematical relation here we can use it. So that type of mathematical relation we use it for implementing your all the public and private key. We discuss in the next example of RSA algorithm how it was done it. Okay, so once the ciphertext come to the user B, it can perform some decryption algorithm along with one key, another one key here. Okay, that key is nothing but recipient private key. Recipient's private key is used to decrypt the do the process of decryption algorithm to get your plain text. So whatever the user is in the plain text, that was we can get it in the user B. So this is what happens in the encryption in the public key cryptography. So in the public key cryptography, normally encryption algorithm use it in the recipient public key. Decryption algorithm use it in the recipient private key. So this what mathematically related. Okay, this what mathematically related. These two keys are mathematically related. So automatically, then no other person can to get the information or to decrypt the messages. Okay. So this is how the encryption done it in the public key cryptography. So you can see one or two difference in the symmetric and public or asymmetric. Okay. So in the private key, okay, the private key, the same algorithm and the same key is used for encryption and decryption. But in the public key, only one algorithm used for encryption and decryption, but the two keys used for encryption. That means one key is used for encryption, another one key is used for decryption. Another one point is here, the sender and the receiver should share the algorithm key. Okay. In the symmetric key algorithm or private key cryptographic system, sender and receiver should share the algorithm, because same algorithm used in the sender and receiver, the same key is used in the sender and receiver. That means encryption and decryption. But here, the sender and receiver should have only single key. That means that means encryption using one key, decryption using another one key. Okay. Similarly, the key must be here secret. Here also the key must be a secret. But here public key we can using the two keys. Okay, that's the additional advantages comparing with symmetric. Okay. This is what is the difference between the public key and a private key. Okay. So next we discuss another one concept in the public key cryptography. So normally the public key cryptography is used for example, encryption, decryption process, or sometimes it is used for key exchanging algorithm, or sometimes it is used for example, yeah. First we can discuss this point, then we can go to. So what is the main application or uses of public key system means? This is used for encryption and decryption. Another one is a key exchange, another one is a digital signature. Okay. These are all the application of the public key system. What is the encryption? So you can any sender can encrypt the message with the receiver's public key. That is the encryption. Already only we discussed it. Okay. That is mainly to provide a service of which one? Which type of service provided? Once you can using the encryption algorithm. Confidentiality. Okay. Secrecy, you can maintain the secrecy. The data will be secure manner or secrecy manner to send it to the receiver. That is the purpose of to using the encryption decryption algorithm. Okay. Another one is a key exchange, means you can exchange your keys, exchange your section keys. So you can using the two keys are used, but the two are mathematically related. So each and every key is used for encryption, another one key is used for decryption. So that is a key exchanging algorithm. A lot of key exchanging algorithm is there, RSA and elliptic cryptography, then Diffie element key exchange and DSS. Okay. Then digital signature. Digital signature normally sender sign a message with the private key. Digital signature normally used for similar to your the paper document. You can get a signature. Mean what happens? Once you can sign one document letter to send it to your destination or recipient means. So recipient seeing this particular document automatically he assume it that particular letter come from the proper sender who can sign it, because so it's authenticated one. So that authentication will be normally here ensured. That particular security will be ensured in using the digital signature. Okay. Here we can using the opposite key. Here we can use it. That means in the encryption algorithm, the sender's private key is used for encryption. Okay, it is opposite from your the previous method. The previous one to provide a service of confidentiality. Digital signature, the provide a service of authentication. Okay, it is a first initial point. Then we can briefly discuss what happens in the digital signature. Okay, so in the public key cryptographic, normally we provide two services. One is a public key cryptographer security. Security means how to maintain your confidentiality. So normally confidentiality maintain means the encryption algorithm use a recipient public key. Decryption algorithm use a recipient private key. This is what the confidentiality service provided in the public key cryptography. or security or secrecy is maintained in the public key cryptography. So once the confidentiality service provided in the public key cryptography or security or secrecy is maintained in the public key cryptography, how it was implemented means in the encryption algorithm along with any plain text we use recipient public key. So where you can get from the recipient public key means already you know it very well. So some common register is there for that particular organization, all the users public key. So for each and every user generate the private key and public key. Okay, wow. Then public key stored in the directory or registry, the common registry or directory. Private key kept from its own. So the private key is very secret one. Other user in that particular organization not possible to find that particular key. But in the public key, anyone can access. It was available in the common directory, okay, or common registry. So anyone can use the key. So normally any user A want to provide a confidentiality of that particular message means, so normally what it can do in the public key cryptography? Using recipient public key. Similarly in decryption algorithm, so it can be reaching to B. So he has its own private key. So from that it has own private key, he decrypted that particular message to get the output of plain text. So that way the both private key and public key are mathematically related. The concept puriyudha idu varaikum. So another one services you want to provide in the public key cryptography is authentication. Because who can send a message? Suppose A can send a message, after some time he possible to deny the message. I am not sending this one. It was happens in the service concept of the non-repetition. Okay. To overcome this problem, so we can provide authentication services also in the public key cryptography. Okay. So you want to implement the authentication in the public key cryptography. So how to do it? So it was done it by the, that means source private key. So user A send a destination to message to the B naka. How to encrypt the message? The encryption will be done it by the private key of user A. User A inga source. Okay. So the private key of user A, using that key, the user A encrypted along with the message X. Then it can produce a ciphertext Y. Okay. Then the ciphertext sent to the recipient B, user B. So user B decrypt message using which key? Its own public key. Okay, that's the difference between confidentiality authentication. Okay, so decryption done it user A's public key. Okay, அப்போ user A's private key use பண்ணி encrypt பண்ணுவோம். இங்க user A உடைய public key use பண்ணி decrypt பண்ணுவோம். So B is know it very well. The data come from the A. So it's know it very well. Data come from the A naka. Automatically he knows the public key of the A. It can get it from the registry, common registry. Okay, that is certificate authority in Sulu. That is called as a certificate authority. Okay, so normally, okay. So the encryption done by the public key of user A. Okay, this what how that particular authentication will be ensured in the public key cryptography. So the both two services we incorporate in that particular public key cryptography. Rendi combine பண்ணி என்ன பண்ணலாம்? We can use it to perform your public key cryptography algorithm. That means you can have a confidentiality and authentication in the any communicating your messages. Okay, so how it can be done it here? We can either two pair, that means the key source of pair A, that means user A, and the key source of pair of user B, both are available. So initially confidentiality ensure பண்ணனாக்க how to it confidentiality ensure பண்ணும்போது recipient ஓட public key use பண்ணனும். authentication ensure பண்றதுக்கு source ஓட public key use பண்ணனும். In the decryption part, normally you want to perform the confidentiality என்ன பண்ணணும் recipient ஓட private key யூஸ் பண்ணணும் decryption க்கு again authentication க்கு A உடைய that means source உடைய public key யூஸ் பண்ணணும் okay the both are combinedly here we can use it that means we provide a service of confidentiality and authentication up no one can this forgery is automatically avoided. Suppose A send a message to B, so after some time it is not possible to deny it. Similar like that, B gets a message, after some time he denies the message, I am not receiving this particular message. So this type of argument is not possible once you can implementing the confidentiality authentication services in the public key cryptography. That's why here we can using the two keys concept in the public key cryptography. That was mathematically related. Then you know it very well the application of public key cryptography or application and uses of public key cryptography system is encryption. You can perform some encryption decryption, that means provide your confidentiality. Digital signature means it provide a authentication and it provide a integrity. Okay, wow. It provide a integrity as well as authentication. Integrity means the authorized user only change the content. Similar like that, the authorized person only send and receive the messages. He can not possible to forgery it. That means he can't deny it after sending its own message. After some time, it's not possible to deny it. So it was achieved by the authentication as well as integrity. So that is called as a digital signature. Another one is a key exchanging. That application also we can use it the public key cryptographic design. This is the application or uses of public key cryptographic system. Okay. So what are all the main requirements? Now we can go in deep. What are the main requirements for the public key cryptographic system? You understand? So the requirement means once you can read the statement carefully. Okay. So it should be computationally easy for party B, that means user B, to generate the pair of keys. Okay. So normally user A want to send message to B, so user B can generate the pair of key. Okay. Similarly, sender also easily generate the pair of keys. That means private key and public key generated by the A, and it is very easily computationally very easy to generate the pair of keys of B. Okay. So the computationally very easy because the both are mathematically related. Okay. Then third one is here. So it should be computationally easy for receive the decrypt message using private key to recover the original message. Okay. So decryption, what we can do it in the decryption message, recipient today private key use money, we decrypted it. So we can easily get your plain text. Original message in plain text, we can easily get it. Okay. So the computationally it is also very easy. That's a third requirement. So after that, it should be computationally infeasible to determine the private key given the public key. Okay. So whatever the public key is available commonly in any registry, so any user, valid user, that means any authenticated user in the organization can go and accept the public key from the repository area. Okay. So 10 user is there, Naka, all the 10 users public key information available in the registry. So you can go and get it. But whatever you can get it the public key, but it is computationally infeasible to determine the private key. So whatever you can have a public key, but it is not possible to determine your private key. So that is the strong point of the public key cryptographic algorithm. It is one of the another one requirement to determine any algorithm used by the public model. Okay. The next one is it should be computationally infeasible to determine the plain text given cipher text and public key. Suppose you have some cipher text message, okay, then you have some public key value, but it is not possible to your plain text. So you can see the fourth and fifth point. So whatever you can have a public key, you can have a cipher text. இது ரெண்டுமே உனக்கு தெரிஞ்சாலும் it is infeasible to determine your plain text and private key. That's why they're saying the point 4 and 5. So the attacker, what is the meaning? In the cryptanalysis, so the attacker, whatever he knows the public key or cipher text, but it is not possible to finding your, or not possible to determine your plain text and the private key. That's why it is called as a computationally infeasible. In that way, mathematically related to the both keys. Okay. So this what the major requirement. What concept you can using the computationally easy, what concept it is computationally infeasible. Okay. So computationally easy means another generate the keys, public key and private key generated by the authorized user A and B is possibly easy. Then encryption we can done it very easily done it. We can generate your public key and private key very easy. But whatever you can have a public key and ciphertext, it is very infeasible to find in your plain text and private key. Yeah. So this what here we discuss in the requirement for public key cryptography. This is a requirement. Okay. So next we can go for the RSA algorithm. It is an example, one of the example for public key cryptography system. RSA. RSA is a public key cryptographic algorithm. What is RSA stand for? So R means the author name of developer's name of Ron Ribert, and Adi Seimer, Shamir, and A is a Adelman. So the first letter R, A, and R, S, and A. Okay. So Ribert, Shamir, Adelman. So this was developed at USA MIT, published in the year of 1978. He developed the algorithm in 1977 and published in the year of 1978. Okay. So RSA algorithm used by the modern computers to encrypt and decrypt messages. Okay. So using the public key cryptography, it is example for public key cryptographic system, or public key cryptographic system is also called as a asymmetric key cryptographic algorithm. Okay. Asymmetric means two keys are used. One key is a public key, another one is a private key. Okay. This is your actually. So this is what the three author. So Ribert, Shamir, Adelman, who developed the RSA algorithm. So some mathematical relation between public key and private key. You can see abstractly we discuss. Okay. So that was done it by the Euler's and Fermat theorem. Here we can use it. So this is Euler and this is a Fermat. Okay. So once again we review the public key cryptography. So the public key cryptography, also known as a asymmetric cryptography, use the two different key. Okay. It provide to assure confidentiality, integrity, authenticity, and non-reputation of electronic communication and data storage. So the public key cryptography assure the service of security services. You know it very well. A number of security services. What are the number of security services? These are all the n number of or classification of security services: confidentiality, authentication, integrity, non-reputation, access control, and availability. So these services we provided. So in the public key cryptography, normally we use the confidentiality, integrity, authenticity, and non-reputation. For example, in the symmetric model, we use only the confidentiality. That means we perform the encryption and decryption algorithm with the same key. So the confidentiality only maintained. There is no authentication and integrity. somewhat it was breaking. Okay, but here confidentiality, how to provide a confidentiality normally? So can give in the chat box how to deploy the confidentiality in the public key cryptographic algorithm. You can give the answer in the chat box. Then only I am understanding. You all understand the concept. How to provide a confidentiality in the public key cryptographic system. இதுதான் முதல்ல சொல்லியிருக்கேன் நான். Come in the chat box or anyone unmute your audio and give the answer. How to provide a confidentiality in the, because two keys are used. What is the encryption, decryption? Okay, confidentiality எப்படி வந்து அச்சீவ் பண்ணுவோம்? Yes. So now only we discuss confidentiality. என்ன பண்ணுவோம்? So என்ன key use பண்ணி encryption பண்ணனும்? What key we can use it for the decryption? So what key is used for encryption and what key is used for decryption to achieve your confidentiality? Confidentiality is nothing but secrecy. That means encryption. That is one of the achievement. But what key you can use it? Quickly discuss. Encryption, public key, okay. It is a public key used for encryption and private key used for decryption. Whose public key, whose private key? That's important. Then only we can make the difference between the authentication and confidentiality. அப்பதான் உனக்கு புரியும் confidentiality authentication என்ன difference னு புரிய வரும். ரெண்டு காமன் கீ யூஸ் பண்றோம், பப்ளிக் கீ அண்ட் பிரைவேட் கீ. we can generate it and use it. பப்ளிக் கீ வந்து என்கிரிப்ஷனுக்கும், பட் whose key, whose public key, whose private key? I mean, first you can don't make any confusion. How to provide your confidentiality? அதுக்கு மட்டும் ஆன்சர் சொல்லுங்க. So otherwise I can go for the diagram. ஞாபகம் இருக்கா? இப்போ டயக்ராம் பாத்தீங்கல்ல? So encryption using public key is correct. I want to get more deep answer. Whose public key to use it in the encryption? So user A also generate the public key and private key. Okay, wa? User B also generate the private key and public key. Okay, user A send a data to the B network, for example. Okay, the whose public key used for encryption to provide your confidentiality key? Yes. Again, we can go for the diagram. Diagram போணுமா? Okay, once again we can go to the concept. I can come to the RSA algorithm. Okay. So this what the diagram to provide a confidentiality authentication. Okay, wow? Both are combined together. So what we can, how to provide a security, secrecy, confidentiality, எல்லாமே ஒரே மீனிங்ல தான் வரும். Okay, public key for security or secrecy means confidentiality. So how to provide a confidentiality? Encryption used for யாரோட public key யூஸ் பண்றோம்? B is a recipient, A is a source. Okay, so recipient public key is used for encryption algorithm. Recipient today private key is used for decryption algorithm. Then you can provide a confidentiality. Okay, suppose you want to provide authentication naka, encryption used for A is private key. User A, private key. Using the user A source. Source private key use panni, it can perform the encryption algorithm. Source user A public key use panni decrypt panna, that we provide your authentication in the public key cryptography. Okay, it's always remember in your mind. In the one point purinjiruchinaka, everything is easy. Okay, once again I can tell that to provide a confidentiality ke encryption algorithm used recipient today public key. Decryption algorithm used recipient today private key. அப்படியே ஆப்போசிட் இங்க கான்ஃபிடன்ட் ஆத்தென்டிகேஷனுக்கு சோர்ஸ் உடைய பிரைவேட் கீ, டிகிரிப்ஷனுக்கு சோர்ஸ் உடைய பப்ளிக் கீ. ஓகே, this what to provide a authentication and a confidentiality. Okay, now you can understand. Now you can understand. Then you can go for the RSA algorithm. Okay, so normally the RSA algorithm provide a confidentiality, integrity, authenticity, non-repetition. Okay, so the RSA algorithm involve the 4 steps. First one is a key generation. Because the key is not automatically used, first the user can generate the key, then you can use it in the algorithm. Okay, so first part is a key generation. Second one is a key distribution. Key distribution means the 2 keys are private and public key, how it is related with each other. Okay, the key distribution. Then third one is a encryption algorithm. Then fourth one is a decryption algorithm. This is 4 steps involved in the RSA algorithm. Okay, so key generation, key distribution, encryption algorithm, decryption algorithm. Okay, so a basic principle behind the RSA is observation, that is the practical to find a 3 very large positive integer. So here we can take it the 3 large positive integer. One is a E, another one is a D, another one is a N. That means with the modulo exponential for all the integers of M. Because M lies between 0 to N. So E is a private key, sorry, E is a public key, D is a private key, and N is a modulus of N. That means whatever we, at the time of key generation, we can using the 2 large prime number using in the modular exponential. That time, the product of the 2 prime number is called a secant. That we can use for modular exponential. So how the equation you can use it means, so message M, for example, you can take any message M naka. So M power E into D is equal to M mod N. This is one of the modular exponential equation. Using that principle, we using the key distribution operation. Okay. So, so before going to the RSA algorithm, you know, once again, review the concept of all the authentication, data confidentiality, data integrity, access control, and non-repetition. Because it provides a solution, provides a service of non-repetition, integrity, confidentiality, and authentication. Because now we can go for in the application of a public key RSA algorithm. So the RSA algorithm that provide the uses of encryption, decryption, then it uses the digital signature, then it can be used the key exchange also possible. But some other method, for example, defilement key exchange is only the key exchange algorithm. It is not for encryption and digital signature. But the RSA is used for both these 3. Okay, the encryption, decryption, digital signature, and the uses. Okay, key exchange. So that's why first we can take it the RSA algorithm. Okay. Similarly, DSS, digital signature, it is only used for digital signature purpose, not for encryption and key exchange purposes. These are all the some application used in the for the public key cryptography system. Rida? So where you can use it, so here you can use the PGP, S-MIME, a secure socket layer, then in digital signatures, everything we can use it. Okay. So normally at the time of key generation, we require the two large prime numbers P and Q, because the modulus of n, so n product n obtained from these two large prime number. These two large prime numbers used are chosen by the only by the users. Okay. So once you can take the two numbers, we can check that particular two numbers is prime or not. If it is a large bit number, how to determine? So normally using the Miller-Robin method to test the primality. Okay, after that we can use it. That means the product of P and Q, n, we can take it as a modulus to this particular equations. Okay. So now go to the brief steps involved in the RSA algorithm. Okay. The first step, first you can select P and Q. What is P and Q? P and Q is here both the prime number, because the first part is the key generation part. You know it very well. Okay. So key generation part, it includes the key distribution part also. Okay. So key generation part, first you can say any user can select the two large prime number P and Q. Okay. How to determine these two number is P and Q naka? Using Miller-Robin method, you can test it, and then that particular number is prime naka, then you can use it in the P and Q. Then second step is here, you can calculate n value. So n value is for modulus, that means the product of this P and Q. Okay. So n is equal to P into Q. So next step, you can calculate your n. N is equal to P into Q. So next we can calculate the Euler-Torsion function, pi of n value. So after we can calculate or determine the n value, then we can determine your pi of n. That means Euler-Torsion function. Third step. Okay, pi of n is equal to, you know it very well, the formula. So P minus 1 into Q minus 1. So after we can determine your performance, next user can select the integer e. E is nothing but public key. Okay, it is chosen by the user only. Okay, E is a public key. The public key is chosen by the one of the integer that is chosen, is a chosen value. It is chosen by only by the user, but it can be satisfy some condition. So what condition it satisfied naka? That E value, that means first we can perform GCD of pi of n comma E. Already we can calculate the pi of n value. Okay, now you can choose any one value E. You can choose any one value E, that means public key value. How to choose naka? It can be satisfy the following condition. So first condition, if the GCD of pi of n comma E is equal to 1. What is the meaning of GCD of pi of n comma E is equal to 1 naka? E is relatively prime to pi of n. Already you know it very well. Okay. E is relatively prime to pi of n. Okay. That's only, that means the common factor E comma pi of n random, it will be get 1 naka, then we can choose that particular E. Purida? So not like that, then you can also take another one condition. E lies between 1 to pi of n. So E lies between 1 to pi of n. Same time, GCD of pi of n comma E is equal to 1 and then the rend condition it will be satisfied. Then we can choose the E value. Okay, it is a calculation part. After that, we can calculate the D value. That means the public key value. The public key will be determined using this formula. That means D is congruent to E inverse. That means it is a reverse process of the particular public key. So you can calculate your private key. It's performed by the reverse process. So D congruent to E power minus 1 mod pi of n. Okay. This is your key generation part. So after generating your keys, how to represent your public key means KU, public key, KU. Suppose user A, so user A's public key is equal to, so E comma n. So E is a public key value, n is a modulus value. Okay. So that is these two keys used for public key. Then private key is K or represent D comma n value. D is a private key determined using to satisfy the formula of D is concurrent to E power minus 1 modulus of pi of n. So we can get the value of D, then use the value of n. These two values used for private key. So using these two, private key and public key, used in the encryption. Encryption means normally, suppose you want to provide a confidentiality naka, என்ன பண்ணலாம் user B உடைய user B public key is used for encryption, then the decryption process la private key used for decryption. புரியுதா? That's why the plain text M ங்கிறது plain text that will be get it from the user A ன்னு வெச்சுக்கோங்க. Any text you want to encrypt it M compulsory it is less than n value இருக்கணும். Then you want to get your suppose you can get your ciphertext using the formula. Okay, ciphertext is equal to message power E. E is a public key. Okay, public key of mod n operation. It's a modular exponential, so mod n you can use it. In that way, you can calculate your ciphertext. In the decryption operation, ciphertext is the input. That ciphertext, okay, the power of the key. What key? D is here. Private key. Okay, so the private key is D along with the mod n operation. So C power D mod n to get your plain text M in the decryption operation. So as per our assumption, in the encryption operation, we can using the private key, and the decryption operation you can using the public. Sorry, here you can using the public key. Here you can use the private key. So we provide your confidentiality. புரியுதா? Okay. So once again, I can read out or recall your entire algorithm. So the key generation port generate the two large prime number. You can take the two large prime number P and Q. How to identify these two number is large prime number or not means to attempt with the Miller-Robin method. Okay, to determine both large number integers or prime. That number we can choose it for this algorithm. So after that, second step to find out your n value, n is equal to P into Q. After that, we can find out your pi of n value. That means using Euler's torsion function. That function formula, you know it very well, P minus 1, Q minus 1. Already you know the P value and Q value. So the P minus 1, Q minus 1, you can get the pi of n. That is m value. So choose the smallest e value. But smallest e value, the comb prime to m argument. Comb term to pi of n argument. What is the comb prime? Relatively prime. Okay, that means the GCD of pi of n comma e is equal to 1 argument. Similar like that, 1 is e is lies between 1 to pi of n argument. Once the both condition is satisfied, then only you can choose the e, because then only e is a co-prime to m argument. Then only we can use it. That number is a public. Then you can find out your private D using the formula of dE mod pi of n is equal to 1, or sometime D is equal to e power minus 1 mod pi of n. Okay, so the publish e and n is a public key. Then you can keep in the user D and m as a secret key. Secret key என்ன பண்ணிருப்போம்? It will be maintained by its own. That user e and n is published in the common directory or common registry. So after that, suppose you want to perform the encryption operation means, so message you can using the exponential. Okay, so message power e. E is a value public. Okay, so encryption operation using the message along with the power of public key mod n operation. Okay, similarly decryption operation C power D of mod n to get your plain text from the decryption operation. Okay, so the x and mod y means the remainder of x divided by y. You know it very well already. Okay, so you try to understand this particular logic. Okay, normally the same whatever we discussed previously, some factorial representation here. Okay, pick secret and a random large prime P and Q, multiple n is equal to P and Q. Okay, then we can get a n value useful for publishing. After that, find out your pi of n. pi of p into pi of q, p minus 1 into q minus 1. So pick random e satisfy the coprime of pi of n. Okay, that is a mathematical formula. So e such that the integer multiplication operation of pi of n. So to publish your e. After that, compute your private key. It is a inverse of e. That's why I'm previously saying the inverse of e in z of asterisk means multiplication operation of pi of n. Okay, so e into d is equal to 1 mod pi of n. Otherwise, if you want to d naka, it will go to that side naka. D is equal to e inverse mod pi of n. Then you can get your private key. Okay. So n and e is a public, and d and n is a private. So n is my public key. Use it to send me a message. Okay. So n and d is a public key. Use it to send me a message. So anyone send a message to me naka, he can use my own public key. Then send a message to me. Suppose anyone want to send a message to another A to send a message to B naka, what happens? So A use the B's public key. Purida? So after that, you can calculate your D value. So it is N and E value. Message M. Then you can perform the encryption operation. Okay, this person send it to the message to this person. So this person use this person's public key to perform this particular M power E mod n operation to encrypt the message. Then it will send it to here. Okay. What is the ultimate meaning is M power E of D concurrent. That means M mod n. It is nothing but concurrent M mod n means concurrent of mod n here. What is the meaning is? Okay. So M power E power D concurrent to M mod n. That it represents. Okay. This was one simple explanation. Try to understand to see this figure. Okay. Message hello, the value 2. Okay. First, initially the pair of keys generated. Okay. That is a public. This is a private. So keys on the 5,14, private on the 11,14. So in the encryption process, message on the 2, hello message represented by the 2. So 2 power public key is okay, 5. 5 is a public key mod n value another 14. You can get to 4 value, that is encrypted message. This value is sent it to the receiver side. So it is used for decryption. That means ciphertext 4 along with the private key 11 of mod 14 n value. We can get your original plain text 2. That means the hello message encrypted, then decrypted, then we can get the original hello message in the receiver side. Okay. Now you can see one of the example. Suppose we take 2 large prime numbers. Okay. We take 2 large prime numbers. So P is equal to 17. Q is equal to 11. What is the second step? Compute n. Okay. Compute n naka P into Q. That is a formula. That's a format. So not very well. So okay. So P into Q n. So 17 into 11. 17 into 11, 187. N value on another 187. Next we can compute pi of n. Euler's torsion function use panni you can find out your pi of n. So pi of n another pi of p into pi of q. Pi of p ki p minus 1. Pi of q ki q minus 1. So p minus 1 into q minus 1. So it means p minus 1 another 16. Q minus 1 10. 16 into 10 160. This is a pi of n value. Now I can choose any one value. That value is co-prime of this pi of n. Suppose You can using E is equal to 3 or 5 or 7 or 8, but it can be satisfied the condition. What condition is satisfied? Naka GCD of E comma pi of n. So you want to find out E. Suppose I can choose 7 HM. 7 comma what is the pi of n value? 160. Okay. You can find out GCD of 7 comma 160. It will be get the answer of 1. You can check it. If it is okay naka, then choose the value of E. You can also satisfy the condition. It lies between 1 to pi of n. E is in what value? I can choose 7. But 7 lies between 1 to 160. Okay. So the both condition is true. Then I can choose the value of 7. Similar like that, you can check it. Each and every value in between 1 to 160. Okay. Then we can check the GCD of these two values is equal to 1. Then you can, after determine this value, then that value you can choose it. Suppose 2 or 3 value get 1 naka, any one of the value you can choose it for the E. Reader? Okay, now we can get your public key E is equal to 7. After that, to determine your private D. So D is equal to, you know the formula, D is equal to 1 mod pi of n. Pi of n is 160. Okay. Otherwise, D மட்டும் determine பண்ணாக்கா E வந்து இந்த பக்கம் கொண்டு வந்துடலாம். So D is equal to E inverse of mod pi of n. So as well as again another one condition, D என்னவா இருக்கணும்? Less than 160 குள்ள தான் இருக்கணும் அந்த value. So both value lies between 1 to pi of n குள்ள தான் இருக்கும். D and D. Okay. So how to find out? For example, here we can take it. You know it very well. E value. E value is 7. Okay. Up 7. Okay. 7 mod pi of n. Pi of n on the 160. Okay. Up the 1 என்ன பண்ணிக்கலாம்? இந்த பக்கம் கொண்டு வரலாமா? 160 plus 1. Okay. So 161 வந்துருமா? Okay. So 161 on the. So what value you can get it? 23. How to get it the 23? So any idea? Yes. So D is equal to E inverse mod 160. So this is a simple value. So mathematically we can done it. But once you can get a very large values, it is very infeasible to determine your, very difficult to determine your D value. That's why normally extended Euclidean algorithm. So one of the algorithm is used to determine your D value is to extended Euclidean. Already you know it Euclidean algorithm, GCD. Okay. So it is a extended Euclidean algorithm used to determine your D value to find a D. Okay. So one of the algorithm, extended Euclidean algorithm used to determine the D value. Otherwise, directly we can take the formula. It is a small value, you can using the formula because 23 into 7 is equal to 161. So we can get the value of 23. Okay. So 161 divided by 7, what value? 23. Present per 161 divided by 7, 123. So 23 into 7 is equal to 161. So from this formula, we can obtain the value of 23. Okay. So after getting E and D value, normally you can publish a private and public key. First publish your public key. The K is equal to 7 comma n value. Then not take the pi of n value. N value எடுத்துக்கணும். So 7 comma 187. இப்போ private key value வந்து 23 D value comma P into Q. That means P into Q 187. N, or you can take the P into Q 17 and 11. Both are same meaning. After that, this is only the key generation and distribution. Okay. After that, we can go for your encryption. For example, you can take this example. This example similar like that. You can find out your E value. Okay. It lies between 1 to pi of n. You can get a value of 7. Similarly, you can find out your D value. D is equal to congruent to E inverse mod pi of n. Okay. Otherwise, D into E mod pi of n is equal to 1 ஆகும். So we can easily get, you can solve this equation to find your solution. D is equal to 3. So already you can find the n value is in the P and Q value 3 into 11 naka 33. So Now you can get a private and public key to encryption operation. How to do it? So m is equal to 2 naka, c is equal to 2 message power public key value e. So 2 power 7 modulus of 33, we can get 29. Or you can taking the simple value, means the simple value you can easily done it in the calculator. Otherwise it is very difficult to do some other process to find out your modulus value. Okay, so the simple value 2 into 2 into 2 7 times you can multiply it, then modulus with 33, so 29 you can get it. That is a ciphertext. So in the decryption process, c is equal to 29. So how to using in the decryption messages? Decryption message ciphertext power of private key. The private key is you can use it as a d value 3. That means c power d mod n. Okay, so 29 of 3 power 3 mod 33 is equal to, we can get the value of 2. This is what your RSA algorithm. Okay, this part. So this part we calculated your generate your PNQ. We can choose that PNQ, generate your public key and private key, using the private key and public key to perform your encryption and decryption operation. So normally it provide a authentication. Okay, normally this provide a confidentiality. This provide a confidentiality. Suppose you can perform the authentication naka, what key you can use it? Same private and public key you can use it, but recipient use panna porama or host private key and public key use panna porama. That decide a authentication and confidentiality. Okay, or understand? This was one simple example. Okay. So what are the attack possibility in the RSA algorithm? That means the security of the RSA breaching by the 3 kinds of attacking is possible in the RSA algorithm. One is a brute force attack. What is the brute force attack? So trying to all the possibility of the private key. So the private key is here n bit, for example. So we can 2 power n bit of possibility to find out your any key or plain text. Okay, that's a brute force attack. You know it very well. So the trying all the possibility of the private key to get your plain text. It is a one type of attack is possible. Another one type is a mathematical attack. Mathematical attack normally the factor of product of 2 prime, because it is very difficult to find your product of 2 prime. Suppose a P and Q, you can choose it n, but from the n, how to get it from the P and Q? That is very difficult. Okay, so that we can overcome by or to attack by the mathematical attack. That means the approaches of factors, the product of 2 prime number. That type of attack is a mathematical attack. Another one attack also we can use it in the RSA for to attacking. That is a timing attack. Okay, depends on the running time of the decryption algorithm. So it is a special kind of attack. That means depending upon the running time of the decryption to finding your ciphertext, plain text, from the ciphertext to plain text. Okay, that is a time item. So these 3 attack normally used in that means done it by the RSA by the attackers. Prida. This was another one example for the RSA algorithm. Okay. Once again, we go through it. Okay. So you can take this particular example and do it in your home. Okay. P is equal to 3, Q is equal to 11, E is equal to 7. Okay, message on the 5. Using these 4 values, you can note down the 4 values. P is equal to 3, Q is equal to 11, E is equal to 7, message on the 5. To find your private key and public key, D value, to determine your D value. I already can give this E value. So you determine the D value and then to perform your encryption decryption operation. Okay. To submit in the WhatsApp group. Okay. P is equal to 3, Q is equal to 11, E is equal to 7, M is equal to 5. So detailedly, my expectation is you can detailedly give each and every information briefly. That's very important. Okay, don't give only the result, because the result is already available in the slide also. But my expectation is to detailedly work out step-by-step process, okay, to find out your D value and perform your encryption decryption. Okay, Prida. So this is what your public key cryptographic algorithm, cryptographic method, and then one of the example of RSA algorithm. Okay, then analysis of RSA algorithm.